Lesson 3.1, Task 1, Linear Equations in Standard Form. Graph linear equations. A linear equation in two variables is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. There are many equivalent ways to express the linear relationship between two variables x and y, but the form ax plus by equals c is called the standard form of a linear equation. The table shows examples and non-examples of linear equations in two variables. All right, so on the left you see linear equations. Each of these have an x and a y. On the right, you see nonlinear equations. So each of these have a higher exponent. So there's a cubic term, squared terms, cubic and squared terms. So remember, a linear equation is an equation of a line, and x and y would only be to the first power. All right, rewrite each equation from the left column in standard form as you fill in the blanks with coefficients and constants. Remember to include the negative signs that will keep your standard form equation equivalent to its original from the left column. All right, so equation 1 says 2x minus 5y equals 8. So that's pretty close to standard form. So you can see down here we have 2x plus, and it's going to be negative 5y equals 8, and that just comes from this first equation here. We just take the negative 5 and the 8 and we're plugging it in. All right, for equation 2 we've got something x plus something y. All right, so what they did to put it in standard form, remember it's going to be ax plus by equals c. So the x needs to be moved to the other side. So to do that we're going to add 3x to the other side. So we're going to have 3x on this side plus 1y equals negative 2, and that's equation 2 in standard form. 3x plus 1y equals negative 2. All right, so now it says the next two equations, equations 3 and 4. So let's go back and look at equation 3. Again, the x is on the wrong side. We need to move it to the left side, so we're going to add 1/2 x. So we're going to have 1/2 x plus 4y equals 5. So 1/2 x plus, was it 4y? 4y equals 5. And this puts it in the ax plus by equals c. So in this case, a is 1/2, b is 4, and c is 5. All right, we're going to do the same thing for equation 4. All right, so our y this time is on the wrong side of the equation, so we need to add y. So we're going to have 2.5x plus y equals pi. So we're going to have 2.5x plus 1y is the same as y equals pi. All right, now it says examine the equations in the right column, explain why each one cannot be written in standard form. All right, so we kind of looked at this already. These cannot be written in linear form because they have exponents to a power greater than 1. All right, so that is all for task 1. If you have any questions, let me know. Lesson 3.1, task 2, linear equations in standard form. Graph linear equations. The graph of a linear equation is the set of all pairs of x and y values that satisfy the equation. So satisfy means makes it true. So it says examine the table of the values for 2x plus y equals 4 and its corresponding graph. All right, so they're giving you a list of x values, and they're taking the x value and they're simply substituting it in the equation. Therefore, you can solve for y. So then you have ordered pair x and y, negative 1, 6 will be a point that falls on this line, this linear equation here. When you plug it in, it satisfies or makes this equation true. So you can see 2 times negative 1, they've plugged into x, so that'd be negative 2, and if you plug in 6, negative 2 plus 6 equals 4. That is a true statement. So each x value, they're plugging it in, they're solving for y, and then they're getting ordered pairs. These ordered pairs is going to represent this linear equation. So they've graphed the points and they've drawn the line there, and that line represents 2x plus y equals 4. And you can see that all of those points fall on that line, on that linear equation. All right, so it says choose the words that best complete the sentence. If you substitute the value of x for the first column into the equation in the second column, then the solution of the equation equals the value of y in the third column. So we did look at that here. So if you look at this first example again, if I solve this, I get -2. When I add 2 to both sides, 4 plus 2 is 6, y equals 6. So that's what it means to find the solution. That gives you your y value. All right, the relationship between the first, third, and fourth columns is that the numbers in the first and third columns form the ordered pairs of the points in the fourth column. Okay, so you can see the points in this fourth column here come from your x and your y values. You can see 0, 4 is here, 1/2, 3, and so on and so forth. All right, it says which of the following points would be on the graph of the linear equation? Select all that apply. All right, so we can look at the graph to do this, or we can plug in the points to do this. So let's plug in -4, 10 first. If we go to -4, here's -4, 6, 8, 10. So we can see that it's not on the line. So we can know that that's not going to be a point on the graph. But let's plug in -4 and 10 here. -4 gives us -8. -8 plus 10 is 2. 2 does not equal 4. So the first ordered pair, looking at the equation and the graph, we can see that this is not a point that satisfies or makes that equation true. -2, 8. Okay, let's look. Here's -2, 2, 4, 6, 8 would be right here. It does appear that that point falls on the graph. So let's look again, -2, 8. Let's plug it in here. So if I take -2 and plug it in for x, I get -4. 2 times -2 is -4. Plus 8 is 4. 4 does equal 4. So this point both looks like it visually lands on that line, and when you plug it into the equation, it works. All right, it says select all that apply, so we need to check the last point as well, 5, -6. So here's 4, so if we go out to 5 and go down, there's -2, 4, -6. It appears like it could be, but the graph isn't big enough to see. So let's go ahead and plug in 5, -6 to our x and y. 5 times 2 is 10. 10 minus 6. 10 minus 6 is 4. 4 does equal 4, so it does work as well. So you can see that if the ordered pairs satisfies the equation, it means it's a point on the graph. All right, that's all for task 2. If you have any questions, let me know.